Hi, Joe Cerrone.
And Alan Rosen.
Welcome to CAD-117 Intermediate AutoCAD and our weekly Zoom classroom meeting. Alrighty, so as we take a look at our D2L core shell, we continue to hold our Zoom meetings on Tuesdays at 10:30. And remember, if you would like additional support or additional help, we have in classroom times that we have under student assistance. So for example, tomorrow, Wednesday, we're on campus, as well as on Sunday at the Skokie campus between 9 and 12. So if you do need some additional help, you can come into class. We've released Module 5. Module 5 is on dimensioning mechanical drawings. And we have two mechanical drawings here. And so we have this drawing right here and this drawing right here. And you're to do both of them. This exercise uses what's called ordinal dimensioning, and this is a model that has a lot of hole geometry information, and we also work with slicing. And so here's the video for creating the ordinal dimensions, and then we have some video from last week, Module 4. Outline or calendar will keep you up to date on when drawings are due. They're typically due 2 weeks after we assign them. And so Module 4 is due on the 22nd. And then Module 5 is on the 29th. And then keep an eye on your calendar. The midterm will be in November. And Module 5 is a OPAL assessment, and we'll talk about that. If we look under content, here's our Module 5. I'm just going to touch base really quick in our outline of topics. And so in our outline of topics, if we look at the sequence of topics, we're continuing to work through these different learning objectives. We've opened the midterm practice exam, and that's an unlimited, take as many times as you would like type exam to prepare you for when we provide with the midterm. Okay. And that will be an honor lock midterm. And so here we are on the 17th, Module 5, work the assignments that are in green, do the readings in blue, and then we'll add the assessment to it, which will be the OPAL assessment for dimensioning. Back to Module 5. And so in Module 5, we'll read the textbook Chapter 5. We'll watch the YouTube or watch the video tutorials for how to create the drawings. And then we'll create those drawings and submit them to the drawing folder. And then there's a quiz called Dimensioning Mechanical Drawings. And that drawing will go through an assessment that basically checks to see if we're understanding our learning objectives. And so these are the two drawing assignments. Here's the PowerPoint information. And the PowerPoint information, I'm going to pause really. So in dimensioning mechanical drawings, the learning objectives are to be able to define dimensions and to be able to understand the difference between size and location dimensions. And then look at the terminology within dimensioning, because in the second course for CAD, we apply these standards, and ASME is American Society of Mechanical Engineers, and they define these standards for machine part dimensioning. And then there's just do's and don'ts or basic rules for how you would put dimensions or measurements onto a drawing. And so as we go through, we'll look at a number of these learning objectives, and then we apply them. And so as we look at, the overview, this is our terminology. Dimension line would be this line right here. And then these are called extension lines. These are our arrowheads. Here's an angular dimension. This would be considered a leader, and they're adding some GD and T symbols. And so when we look at mechanical drawing and dimensioning, we're going to look at these fundamentals like location dimensions. And a location dimension is going to locate a feature, and a feature would be something like a hole. And so that accurately locates this 0.75 diameter hole at 2.89 from this edge and 0.84 from this edge. And so as we go through and we learn about technical drawing for mechanical drawings, the textbook author does a really good job of explaining these standards that we're using from the American Society of Mechanical Engineers that basically goes through how you would put dimensions onto a print, things to avoid, like putting the dimensions on the part. And if you weren't told that, how would you know? And so we go through the learning objectives and we learn how the standards are applied. And so when we look at what is preferred, we can see that the dimensions are not on the part, they're next to the part. And then we try to choose views that best describe what we're looking at and how to make it. And so as we look at dimensioning of different features like holes and arcs, we want center marks. Okay, and as we start to work with our CAD system, we're putting center marks on the center mark layer so that we can separate them for if we do prototyping and machining. You know, here's another example of how you would dimension cylindrical shapes. And so this would be like something you could make on a lathe. This would be the front view of it and the right side view. And then notice how we go from smaller, bigger, bigger, so that we don't cross over dimension lines, or it's neater. And same thing with these angular measurements and things like that. So the textbook goes into quite a bit of detail. Here's the detail on ordinal dimensions. And ordinal dimensions are terrific for using in the machine shop. We tie the machine to the coordinate system, and then we can locate these location dimensions for drilling these holes and quickly make these parts with a CAM system. Other information as far as drill bit geometry, things like counter bores and counter sinks. As you get more familiar with the terminology in blueprint reading, a counter bore is a relief and a counter sink is a relief at an angle. And so we'll typically counter bore holes that will have like washers, or we'll have a bolt that will be then within that counter bored hole so that the head of the bolt is flush with the top of the surface. And so as we get into more design elements, we'll look at things like GD and T symbols. This is a counterbored hole, a countersunk, depth of hole, and the job skills that go with that. And so you're going to start seeing these on the job. When I was with Komatsu, you know, we had a specific department that would go through and look at all the tolerances of what you were creating. And so checklist of how you would properly place dimensions. And then when we get into, you know, the role of a drafts person and what they do, it kind of gives you an idea of the job or the vocational aspects. All right, back to module 5. So the PowerPoints go through how to create mechanical drawings according to these standards. And then 5A, let's just look right in the CAD system. Here's our 2 drawings, and you're to do both of them. You're going to use a mechanical B-size title block. If I look at this drawing right here, you don't have to create the 3D geometry, but I think most people are to the point now where they can, but it's still bonus at this point. And then when we look at this drawing in a top view, the key to creating ordinal dimensions is that the origin is at the 0 position. And so when we create ordinal dimensions, we're creating dimensions using the ordinal dimensioning tool, which is right here, ordinate. And the way that the ordinate tool is, it's tied to the user coordinate system. So if I type UCS and then I type O for origin, the origin should be located right here. And then when I choose to put these dimensions on, and I think I'll just go with the dimension layer, and we'll go with red so we can see it. When we dimension ordinal dimensions, they'll be tied to the 0 position. And so you can see as I bring these out, I can then go through and identify some of these different components. It looks like that one's maybe a little bit off. I probably grabbed the end of the extension. So you have to be careful about how you choose the geometry, because if you choose the end of a leader, it will, and that's why we create separate layers for that information. So again, you know, as we go through and we pick up on these different dimensioning techniques, we can go through and we can put these dimensions on here with an ordinal dimensions and put it onto the title block. Double click in the viewport. You're going to want to set the scale. And so this one's locked and set. And we set those scales at 1:1 when we can fit the part in the viewport at that scale. Sometimes we'll have to scale them down, but the idea is that paper space, this is an 11 tall by 17 wide, is an actual physical part of the drawing. And then when we print them out, the drawings will be measurable, meaning if we put a scale on this printed piece of paper, we'll see that it's going to be 6 inches by 5 inches. And if you made the part, you could put it right on top of it and it should line up with all the hole features and stuff. All righty. And then the other drawing is a little bit more involved. And as we take a look at this exercise, we'll be using the slicing tool. And we have videos for this. And so the idea is that we draw the front view and the top view, and then we dimension and annotate it. And then when we look at this drawing, some of the information like the drill bit geometry down here at the bottom and the counterboring geometry down here at the bottom, there's a PDF and the textbook does a good job of it. But just from a quick standpoint, the angular measurement on a countersink is 82 degrees. And then the angular measurement on a drill bit is 118 degrees. And these are things that you'll pick up in the mechanical design information. If you're working with SolidWorks, SolidWorks has what's called a drill, a wizard. And I'm not sure why that's not coming out right. It should be 118. And I had it before. Let's try it one more time. Sometimes if I tag the wrong line, it will give me, and that's what happened. I tagged one of the hatch lines. And so that's how that geometry works. And then if we look at the video, back to the D2L, here's the 5B tutorial. And we walk through creating the geometry for that, and the angles and the measurements. All righty. The OPAL assessment is under quizzes and exams. And so we want to turn this around by next week. And so here's the dimensioning mechanical exams. And please read through the exercise or through the reading chapters before you take the test, because you will have 2 attempts. And we're just using this to report that people are able to follow the curriculum, and we'll use that information. And so when we look at the mechanical dimensioning exam, and if I view this as a teacher, I can look at the questions under quizzes and exams. Here's the exam. And then it's going to ask you written responses. So it won't be automatically graded. Al and I will have to go through and grade these things. You know, things like, what does the term CAM stand for? What is a reference dimension? All righty. So module 5 is active, and it's located here in D2L under module 5. And we're going to work with mechanical drawings. Next week, we'll work with architectural drawings. Be sure to take the OPAL assessment down here. It links as well. We're learning how to embed the quizzes in here. If you have any questions, feel free to email us, ask for a Zoom meeting, or come in person. Al, is there anything else that we want to talk about before I stop the recording and we open things up for questions?
No, not at all.
All righty then. I'm going to stop the recording and we'll open things up for questions.